Hi guys, welcome back to another video. This will be Calculus 1 Unit 1, and this is limits. So this is our lesson plan for today. We're first going to learn what limits are and how to find them. Then we're going to learn how to find them using direct substitution, learn a couple limit theorems, the factor and cancellation method, the conjugate method, and trig limits. Okay, so what are limits and how do you find them? Limits are essentially where points meet on a graph. So if we have a graph here, and this is our graph, let's just say it's y equals x for simplicity. The limit, this is limit notation, as x approaches 2 of y equals x is what? It's just going to say x when it asks you. And the limit as x approaches 2 of x is just going to be 2. That's because here at x equals 2, y is approaching 2. Okay? Now, it gets a little bit more tricky than that, but that's the general gist. Okay, so now that we know how to find them and what limits are, because limits are just where the graph is approaching, like where would it be if you plug it into the equation. And an example of what we'll be finding in future is, let's say that a graph looks like this and it has a hole at this point. Now, in an actual graph without the limit, you would just say this is infinite or does not exist. But with limit, it's still equal to 2, because from both sides here and this direction, the value is going to be 2. Like, imagine it's if you were walking a path and it's assuming what your next step would be if there was nothing in the way. So now, let's try out a couple problems that are more advanced. So limit as x approaches 2 of this function. It's really as simple as just plugging it in. So as x approaches 2, you get 3 times 2 squared minus 5 times 2 is 10 plus 4. So 2 squared is 4 times 3 is 12 minus 10 is 2 plus 6. What do we say? 2 plus 6, which is equal to 6. Okay. This goes for all things now. So when we do limit as x approaches e, it's just the natural log of e over 3. And the natural log of e is just 1. 1 over 3e will be our final answer. And for our last one, you just plug in 4. It's the cubed root of 4 plus 4, which is 8, which is equal to 2. Okay, so for most of these ones, these are really easy and you're not likely to see it. This is more just so you can understand the concept of limits. Limits are where it should be approaching when that x is the value. Okay, so now we're going to go to a little bit more complex in the real limits. Okay, so here we get the idea of one-sided limits, which is when you see these plus and this minus. And the plus means when approaching from the right side, and the minus means when approaching from the left side. So what that means is that, let's go back to our y equals x graph at x equals 2. So approaching from the right side means that if this is our x, it's as if you were coming from the right, and minus means as if you were coming from the left. So negative up, right up, what would the value be? And the reason you need this sometimes is on like piecewise functions, for example, where it goes to here and then jumps to here. From the right side, the limit would be right here, and from the left side, the limit would be right there. Okay? So now let's look at these problems. Okay, so for this one, we're going to try what we did before when we plugged in 2. That's going to be 4 plus 2 plus minus 6 is going to be 0 over 2 squared, which is 4 minus 12 plus 8. So 4 minus 12 plus 8. And that's going to end up giving us 0. Now, we know from past maths like pre-calculus and algebra, 0 over 0 is not a real number. It does not exist. but that's not good enough. We need to find what the limit is. Okay, so I'm going to jump down a little bit. So first, we're going to see what it is if you factored it. So here we're looking for any ways we can remove this. So here we got x equals, adds to be -6, or adds to be, or multiplies to be -6, adds to be 1, and that's going to be 3 minus 2. So x minus 3, x minus 3, x plus 2. I messed it up. X plus 3, x minus 2, over, and then on the bottom one, we're going to have adds to be -6, multiplies to be 8, and that's going to be -4 and -2. So x plus, or x minus 4 times x minus 2. So now that we factored out, we can see that there's 2x minus 2. These cancel each other out, and you're left with x plus 3 over x minus 4. Now we plug back in this 2 again, and you get 5 over 2 minus -4 is -2. And that's what our real limit is at 2. Okay, I'm going to erase this to give us some more space. Now we want to find out what it is from the right side, because we have this plus here. So from the right side, we're going to be looking down and coming from the right. So we already know that when we factor this out, it's going to end up being x plus 3 over x minus 4. But to solve from the right side, we just want to add 1. What I do is I add 1 just to see if it's coming down. Okay, so from 5, when it's 5 plus 3, it's 8 over when it's 8 over 4. Oh, see, here's the issue, is that 4 is also an issue down here. So when it's coming from the right, 5 minus 4 is going to be 1, so it's going to be 8. And then, so we know it's going to get smaller and smaller. So now we'll plug in 4.5. 4.5 is going to be 7.5 over 0.5, which is going to be 15. Then you plug in a smaller number. Let's go 7.1. 7.1 plus 3 is going to be 10.1 over 0.1. And as you can see, the numbers keep getting larger and larger, which means that this limit approaching from the right is going to be equal to infinity, positive infinity, because it's going up. So now let's look at it from the left. The left, we will do 3.5. So let's go back to our easier divided up one, x plus 3 over x minus 4. Okay, so 3.5 plus that is going to be 6.5 over negative 0.5. And as you can see, just like before, this number is going to keep getting larger, and this number is going to keep approaching 0, which means that it's going to negative 0, I might add. So that means that it's going to be negative infinity. Okay, next let's look at piecewise functions. Like I said before, these ones are going to look like this, where it's here to here to here to here. And the reason these ones you kind of need to use limits, and it matters where they're coming from, is because look at this one, you can't say the limit. The limit when it's like there's no plus or minus here would be does not exist because they are not jointed. You could only find the limit from the right and the limit from the left. Okay, so now let's look at these ones. So when x is greater than 1, it's x cubed plus 1. So it's going to look something like that. And when x is less than 1, it's going to look something like that. Now we're checking to see if they're jointed, basically, is the important part. And they're jointed is if at x equals 1, they're equal. So now we're just going to plug in them both for 1. So 1 cubed is 1 plus 1. x is 1, 1 plus 1, they both equal 2. Because they both equal 2, that means that they meet here at x equals 2, and their limit is 2. Okay? So now let's look at a little bit more tricky of a one. Okay, so now we're going to plug in 2 for both of these. 4 minus 8 plus 7 minus 4 plus 8 minus 1. That's going to give us 4 minus 1 equals 3. It's going to give us 15 minus 4, or no, it's going to equal negative 1 minus 4, or negative 1 plus 4 equals 3. So they both equal to 3 when x equals 2. So that will be our limit there. Now, imagine that this was 4x plus 2, and this was plus 2, and then this equaled 5. Now they're no longer limit, so the limit at x equals 2 does not exist, and that would be your answer. So just make sure to look out for that. Now let's do some factoring and canceling. We looked at it before, kind of, when we were doing the ones from each side. But basically, you're just going to try and factor both the top and the bottom and see if you can cancel out anything, which will make it easier, and then plug the number back in. So for this, we need to know 2 times that would be, so it needs to be equal to negative 8 and 7, and that's just going to be 8 minus 1, okay, and then divided by 2. So it's going to be equal to 2x minus 1 times x plus 4. 1, okay, and then we'll do the bottom, which is, it needs to add to negative 1, multiply to negative 20. It's going to be negative 5, 4, so x minus 5, x plus 4, and we have x plus 4 over x plus 4. These cancel out. Now we can plug in negative 4 here. Negative 4 times 2 is negative 8 minus 1, negative 9 over negative 4 minus negative 5, which is also negative 9, and we're left with 1. So the limit as x approaches negative 4 will be 1. Okay, now let's look at this one. X cubed minus 27. Now, this isn't one that you can just factor out, but you can get rid of a cube in there. So it's x minus 3 cubed. And on the bottom one, you get, needs to be 1 multiplied negative 12. It's going to be 4 minus 3. So we get x plus 4, x minus 3. And you can cancel this out with this, and then this squared. And now you're left with x minus 3 squared over x plus 4. And that will now equal 0 over 7, which is a real number. It's just 0, when before it would have been something over 0, which does not exist. Now let's look at the conjugate method. Now this is mainly for when there is a root on the bottom, and we learned a little bit of that in pre-calculus. So for this one, the first one, negative 1 on the bottom clearly is not going to work. So we need to find something to do that will work. And we can do this by timesing it by itself. So that's negative x plus 2 minus 1 over square root x plus 2 minus 1. And that will give us x plus 2 plus 2 root x plus 2 minus 2, or sorry, plus 1. And then on the bottom, we get x root x plus 2 plus root x plus 2 minus 2 or minus 1. And now, while it is a much longer fraction, there's guaranteed to be not an x value that's 0 on the bottom or a negative fraction. So we can actually solve. And when we solve this out, it'll end up being 1 plus 2 times negative 1 minus 2 plus 1. So z equals 0 over, this will end up being negative 1 times negative 1, which is just 1 plus 1 minus 1, which equals 1. So 0 over 1. So the limit is 0, but it's an actual limit. It's not a non-existent limit. Okay, so now let's make some more space on the bottom. Okay, for this one, do the exact same thing, except we're timesing it on the bottom. So the conjugate is plus root x. Oh, this should have been plus up top, but it still works because it's a 1. So 3 plus that minus 4. 3 plus root x minus 4. And that will give you 3 times 3 is over 9. These two are going to cancel them out, and then you'll be left with x plus x minus 4. And as you can see, when you put in 5, it's going to be 9 plus 5 minus 4, which is over 10, which means the top, whatever it is a real number. I'm not going to solve it out because I did it up here. But basically, you're just looking on the bottom to make sure it's a real number. There's nothing on the top unless it goes to the negatives. That's not going to be real. And it's going to end up being the same with this. You're just going to times it by the negative version of this. And that will give you the answer. Now, what you sometimes need to look out for, we've gone over when it's over 0, but another way that it could not be real is if it's the square root of a negative. So any imaginary number will give you a limit or a not real number. So you need to look out for those, and you can find other ways to go around it, but most of the time you're going to have to go inside, square it, get rid of it somehow. Okay? So lastly, let's look at trig limits. These are not really things that you solve for anything. This is just things that you need to know, because they'll occasionally put in a calculus exam, is they'll leave you with the limit, they'll leave you with these limits, and you just have to know that the limit as x approaches 0 sin x over x is 1. Even though x is 0 on the bottom, you just kind of need to know that. Same with the 1 over cosine x. There's really long, complicated math that I don't have time to go over in this video, but just know, like, you don't need to know why it's equal to 0 or equal to 1. You just need to know that it is. Okay? If you guys enjoyed this video, please like and subscribe. Thank you. Stay tuned.